Hello everyone, welcome to our webinar on corridor design using LiDAR. So today's Softree 30-minute seminar will cover some easy techniques for using LiDAR data in RoadEng. We'll be recording the webinar and we'll send everyone a link in case if you'd like to watch it again or pass it on to someone who wasn't able to attend. So before I pass it over to my colleague who are actually performing the demonstration, I wanted to introduce a few concepts to help you make the most out of your LiDAR. So the first concept is to just simply use raw LiDAR and avoid using any gridded data. As we can see here on the screen, the gridded data, which are these little points, is not improving the quality of our data at all, but rather it's adding a tremendous number of points to our model, so it will slow down the terrain modeling process. So on to tip number 2, which is selectively thin your data. So most LiDAR data sets are huge. Naturally, the fewer points in your model, the faster the model works. RoadEng handles a maximum of around 10 million LiDAR data points just with an average business computer, so it's pretty great. And it's quite advantageous to selectively thin your data to speed up your terrain modeling process. We're going to show you an option for thinning your data after importing at full resolution and around the corridor of interest. Our third tip, and this really works only with ASCII data sets, but you can combine features when importing to save on memory. Now, we won't be covering this part as we're working with LAS file, and this imports as grouped features automatically. And if you're working with LiDAR data and a field traverse, your LiDAR data can be used for the cross sections, while the traverse can be used for calculating offsets. We're going to show you an example of this process at the end of the demo. And finally, we come to our last concept, which is georeferencing your LiDAR data, which would allow you to bring in background orthophotos. You'll be able to export to Google Earth, export to your GIS, combined with other data sources. Basically, it gives you tons of options. And now, without further ado, I'll pass it over for the actual demo.
Thank you, Andy. Okay, I hope everybody is looking at my screen now. I'm going to start with our terrain module. I'm using version 9. You may have seen that on the screen for a second there. Good, everything seems to be working just fine. So I'm going to open up a design that has almost 5 million points in it. And I'm going to skip the file import because it takes a little while. And I did want to show you how to thin data after you've done the import. So that's where we're going to start. And this file has been imported from LiDAR data. It's full resolution. All the points have been imported. And you can see we've got just over 5 million points total. They're not all LiDAR points. If I select the contours, you can see that the number of contour points is quite significant too. We've got 200,000 of those. Okay, so how would I thin this data? Well, at import time, you can thin around areas of interest using features. And I have a feature in here that's quite useful. It's a proposed road alignment. And I'm going to use that same feature to thin the data after import. So you imagine we've just imported all the LiDAR data. We're below the threshold of blowing up the computer because of out of memory. This is always a problem. Not always a problem, often a problem. If you have 25 LiDAR files and they all have 5 million points in them, you're not going to be able to read that data in all at once unless you do the thinning at read time. For this example, we were able to bring in all the data, and now I'm going to do the thinning after the fact. I'm going to use our, whoops, I clicked on the wrong button. I'm going to use the terrain modeling simplify. Oh, well, I might as well mention this while I'm here. This button I clicked on by mistake is the new Live Maps import that allows you to bring images in from various sources. This is Google. Notice that the well, you can see a couple of things over here that I don't know what the heck they are. That's interesting, those little triangles. But when I switch over to Bing, the image is a little different. Bing is more up to date. There's been some import of recent air photos into the Bing database, and you can see the wind farm has progressed somewhat. Okay, right. So I want to show you that anyway, but I'm going to close it off now and go back to thinning. So that's our new Live Map import available in version 9. Now back to thinning. So from our terrain modeling ribbon, I can click on the Simplify button here. This is the same place you do your contour generation, grading, merging, and so on. And there's the Simplify button. And that allows me to simplify in two methods here. Well, unless you can't remove all, that's a very simple process. But anyway, two different kinds of thinning. And I'm going to use the simplest one, basic grid format. Seems to work very well. And if I just choose a grid spacing of 2, what I'm doing here is slightly different from that image you saw in the original PowerPoint. I'm not introducing new points that might lie between the LiDAR points. What I'm doing here is I'm just dividing the screen up into a grid, 2-meter spacing grid, and picking one point out of each grid cell. So this is going to reduce the number of data points, and there will be at least 1 point for every 2-meter grid cell. They will be the original LiDAR points that are left over, but there will be fewer of them. Now I'm going to add a corridor because I don't want to thin everywhere. What I'll do is I'll pick that centerline corridor that I showed you a second ago, and I'm going to make that into a full resolution swath of data, 100 meters wide. So there we go. This is not going to be thinned. Everything else will be thinned. So this is an excluded region. And we're going to go down to 2-meter grid. Let's just do that. It goes really fast if you don't have a thinning corridor or other excluded zones. But when there are excluded zones, it has to do a little bit of work. It has to check every point. And there, it's finished. Right, so it doesn't look any different. Let's zoom in and see what we've actually done here. So you can see there's the corridor center line. And now I'm going to select all points, Control A. And it's quite clear that the data is more dense near the proposed corridor and less dense outside. Now, it's interesting to know quantitatively how good this surface is. So what I'm going to do now is kind of interesting. I'm going to subtract this surface from the original ground, or from the original full resolution LiDAR. So first of all, let's make a surface. We do need a surface. I don't need contours. Okay. And we can look at the surface. It's a typical 3D surface of an area. We've got fewer points now, less than 1 million, or pardon me, just over 1 million. There it is. Now, how can I tell whether this is better or how much worse it is than my original. Here's how I do it. Save as regular grid. I've already done this, so I'm just going to call this one demo, and we can open the other one if it works. This one doesn't work, I should say. So regular grid export allows you to, among other things, compare two surfaces. So I'm comparing the current surface, the thin surface, with lidar all, which is everything. And I'm just going to take the defaults here. I'm going to get 10,000 points, and we'll see what it looks like. I could have also shown you the two terrains overlapped and hovered the mouse to see the differences. Here we go. There's my 10. Well, it would have been 10,000 if I had this little section in here, the corner that's missing. Now let's make a surface out of that. Terrain modeling, generate surface. Again, I don't need contours. My points were about 25 meters apart, so let's skip anything over 40. And there's the surface. Now this surface is basically flat. It's not very interesting to look at in 3D. But what is interesting is how big are the elevations. So here's an elevation that's minus 0.001. Here's another one that's 0.004. So all these elevations are small. That one looks like it's one of the bigger of the 0.06. Yeah, still quite small, well under a decimeter. I'm going to display this in a way that shows me the differences. This is a cut fill map, and I want to display shading for elevation. Notice that this part of the software, tin shading, shows me the range. So right away I can see that the biggest difference between the two surfaces was half a meter. And I can generate a range here and show what this looks like. Now this is not actually a very useful color map. I made one earlier that I think is better, so I'm just going to use that. So let's go to my screen layouts here and pull in the color map that I created earlier. And I think this picture describes exactly what we did. There's differences between the surfaces in the bulk of the surface, in the bulk of the area, but on my corridor there's no difference. So if I select a point in there, the elevation of that point is 0. No difference between original surface with all the lidar points and the thin surface. However, if I click on this bright red point here, it shows a difference of almost half a meter, and this is a positive difference. And if I click on one of these dark green points, it's almost half a meter, and it's negative difference. In other words, if I start doing road design or some other surface draping operation outside of my corridor, I've got a little bit of error from my original lidar. Not that the lidar was perfect. Lidar has errors built into it, probably around 15 centimeters in elevation. And of course, the points are not infinitely dense, so there are spots that are missed. However, in my corridor, I know that I'm getting as accurate as possible. Okay, back to the, let's go back to that file that I created. Oh, actually, I don't need to show you this anymore because the other one's still open, I think. Oh no, I just haven't contoured it. That's right. Well, let's open the one that I prepared a few minutes ago. And it's this one. So once again, this is the LiDAR data that I created by thinning selectively. So if I show all the points, oh, that doesn't look right. Oh, maybe I opened the wrong file. Oh, just a sec. LiDAR thinned corridor. There it is. Right. So once again, we've got dense data near the in the corridor and not so dense, thin data outside, and that has given me a data set of just over 1 million points instead of 5 million. So it goes a little faster when I'm redrawing the screen, when I'm draping features, etc. Even when you save, it goes a little bit faster. Now let's go on to what we can do with this LiDAR file. We're going to create a location design on here. So it's already saved. Let's go over to the location module and do it. Again, I'm working in version 9 beta software. The stuff I'm showing you is available in version 8 unless I mention it, like for example live maps. So I want to create a brand new location design. Working from LiDAR is great because you can basically design a road anywhere inside the surface, so you don't need an original alignment. However, if you have some alignment information, you can read it in. I think what I'll do is I'll bring in a land.xml file just to illustrate that process. So this land.xml file contains curves, and both vertical and horizontal, and it was created somehow. Our software will export land.xml, but this was probably created in a third-party software, for example, Civil 3D. And you can see that I've got a horizontal alignment automatically brought in. I don't think there was any vertical in there, and you can see that the vertical alignment is undesigned as yet. Now let's talk about templates, because the original ground surface is certainly important. We need to know more about the original ground, and I'll talk about that later when I talk about creating a survey to go with the LiDAR data. For example, we might need to know where the rock outcrops are, where the swampy bits are, peat, etc. But for now, let's look at the cross-section. So horizontal alignment is great, but if we don't have a reasonable cross-section, it's going to give us a road that we don't want. So here's our template editor. It's also available from the ribbon, Edit Templates. Now you can set up a template table, and they end with TPL. And the one you get by default is called normal. So that's what I'm looking at here. But you can modify your templates. I'm just going to bring in some roadway components here from our website. There they are. So these are all different roadway components that you can put into your template. And this is a access road. We're accessing wind farm platforms and windmills. So I'm going to copy this particular resource component, and I'm going to delete the existing roadway and paste the new roadway in there. And I'll do that on the right side as well. So as you can see, I can very quickly build a template by copying and pasting components, and our software has a bunch of components available on the web that you can work from. Each component has properties. For example, this resource component has a width, So if I wanted to change the width of my template, I could type in a different value here. Oops, that's way too big. Get the idea. And the components in this template are roadway, ditch, and slopes. They light up in pink when you select them. The ditch is automatic in the sense that if my road is high enough above the ground, the ditch disappears. The slope component has two values. One is the fill slope, one is the cut slope. There it is. Okay, I'm happy with this template. And now I can go on and design my road. So we've already got a horizontal alignment here, so really the only work that needs to be done is to design the vertical. Designing the alignment is as simple as clicking with the mouse, click to create a point, move it around to where you think you want to anchor it, and click a second time to anchor it. The software calculates all the cross sections in between, starts calculating volumes, and it doesn't take long to design, well, it takes a while to design a good road. It doesn't take long to design something. And I can throw in curves too. Let's look at vertical curves. So I'll put the default vertical curve on there. That curve came from my template table. So once you've created a set of vertical curves that you like, you can save it. You can say that's my default curve. Click on that button there, and the next time you save your template table, that gets put in there. Or if you like, whenever you open a template table, you get default curve parameters. Yeah, so there we have a quick vertical alignment. But remember, this came from a horizontal alignment that was provided to me. Kind of cheating. I didn't have to do any of the horizontal alignment, and that's the hard work. So let's take a look at creating this design from scratch with no alignment to start with. Again, I'm going to work from that same terrain. I don't need any initial alignment. I'm going to start from the center of the terrain. There we go. And I'm going to start at the top of the hill. Click to capture, move it over here, click to anchor. I'll start up here. And I can design my horizontal alignment the same way I did the vertical. Click to create a point, move it to where you think it should be, click to anchor it down. Now that's very interesting, except I'm not getting the kind of feedback I need. I'd like to be able to see the profile at the same time. Oh, there it is. I'd also like to know just exactly what grade these are at. And I have options in the plan options here to turn on labels and so on and so forth. And eventually I could, with a few clicks, get the screen set up the way I like. However, I don't have to do that because I've saved a screen layout. And that screen layout, called pegging, has my windows arranged the way I want them. And it has the labels turned on that I wanted. So now you can see that as I move a point around on the plan window and re-anchor it, the grade updates. Now let's start going down the hill and see what happens. Okay, there's minus 9%. If I go straight down the hill, it's minus 22%. If I go up the hill, of course, then we're going to have, don't need those displayed, plus %. And if I follow the alignment that I have in the background, it's about 11% there. Maybe I want to keep my grades under 10. There we go, there's 10.2. A tiny bit up the hill, now it's 10.0. Some schools call this pegging. and you can see our software makes it easy to do that. The RoadEng module allows you to change the alignment on top of the LiDAR file, watch the profile grow, look at the grades, see where you are in all three windows. So for example, there's a little bump here, a little dip. If I put my cursor in the dip in the profile window, I see the same point displayed in the plan window. So I know that if I put a point there, move it up the hill a little bit, that dip will go up. Similarly, there's a rise right here. So if I add a point there and move it down the hill a bit, my grade again flattens out. So I'm controlling the ground line in the profile by adjusting the horizontal alignment in the plan. And you can do this while you're looking at a background file. So here, for example, is an image. One little mistake I always make here, I think I want the image to be displayed after shift down the contours. Now this is a bit out of sequence because the image file is showing the built road while I'm drawing the alignment on top of the original ground without the built road. Anyway, you get the idea. We can add curves. Let's put in a couple of curves here. When you're designing curves, you put in fewer intersection points, and then you add, now I'm going to change screen layouts again, because I don't like this one for adding curves. And I'm going to turn off those the image too. So even though I can keep the image in the background, but I can turn off its display and then turn it on when I want. There we go. Okay, so now I've got these intersection points here, and here's my horizontal curve panel. If this doesn't exist, you can just click on this little button down. Where the heck is it? This one. Horizontal curves. Okay. Let's add the default curve, see what it looks like. Well, that's 200 meters radius. Let's just change that to 100, see what it looks like. Looks good. I like that. Let's set that as my default curve, go back 1 point, get my default curve, and apply. There we go. So yeah, you can put horizontal curves in similar to vertical curves. Now, one point I like to make here, I've been working with the mouse. I've been just doing things by the seat of my pants, by my eyeball, taking a look at this stuff and moving things around, see how it looks. But at any point, you can type in coordinates for intersection points. In the vertical curve panel, you can similarly type in station elevation. So you can work from well-defined control points if you need to. Okay, I'm just about at the end of our half hour, and now I want to tack on something a little bit oriented toward forestry or other resource roads, and that is creating a P-line traverse in the background. But before I go on, if you have any questions at this point, please feel free to enter them into the questions panel, and we'll try and answer them. So just in summary, LiDAR allows you to design a road in any direction. You can peg in the alignment horizontally, and then once you've done that, you can design vertically. And we can put in horizontal and vertical curves. There's a vertical curve. And you can watch the volumes changing as you make changes to your alignment. Everything is up to date, all the cross sections along the way. I didn't bother to change my cross section here. Let's just do that, see what happens. So I'm going to go into my template table, and this time I'm just going to open the table that I want, which is that one. The template is already set up as my default template. There's a lot more to cover in how you can configure your road. Namely, you can define what materials are in the ground. You can change the templates along the alignment. You can change other things along the alignment. But let's say we just wanted to get some ground information into the software. So now we're going to be going back to the field and entering data from our survey map module. Now, the survey map module is a very low-level traverse program. And when you start a new traverse, you need to enter coordinates. And you can get these coordinates from GPS if you've got one hooked up in your, well, if you've got one handy. I'm using the desktop application here, but Survey Map also allows you to work from a tablet. We've got a iPad tablet version. And of course, if you've got a Windows tablet that's running Windows 10, you can run this software in the field. A lot of people just take paper notes. So a typical P-line traverse has azimuth, distance, slope, and side shots. Now, if I wanted to pick up information about the ground where I've already got lidar data, then the side shots aren't necessary. So let me open a P-line that I created just a little while ago. And it's opening the map too. That's nice. Oh, I think I opened the map instead of the traverse. Let me try that again. That one. There we go. So here's a traverse that I just threw together with azimuth, distance. Notice that the slope is set to 0. I don't even need to pick up the center line elevations with my Clino if I've got lidar in the background. So here's the plan. Let's just tile those so you can see them both at the same time. And I'll enter another shot. You get the idea how it works. So we're at the end of the traverse here, and let's say we're going off at about 45 degrees for another 100 meters. I don't know what slope it is. Put in 0, and there it is. It's put in this little shot here. And when I select that point, it shows the current point there. In other words, I can display, if I brought my Windows tablet into the field, I could display my lidar data while I'm entering this traverse information. Now, picking up the center line is probably not that important, but while I'm doing it, I can pick up, well, I guess it's, let me rephrase that. I'm walking on the ground. I can probably see better where I want to go than I can see in the original lidar with an air photo. And so I can fine-tune any possible alignments that I might have, or pioneer a new alignment, and just as I would do if there was no lidar data, and survey in the field where I think this thing should go. Meanwhile, picking up information like ground type, where is there a rock outcrop, where is there peat, picking up other information which I can put into comments, and all this stuff becomes a little bit of ground truthing that I can refer to when I go back to do my road design. The other thing that I can do, which is, I think, key to mention at this point is that I can adjust my coordinates by typing in X, Y, Z values at any point. And generally, if you're working in the field with a GPS device, that's where you get your coordinates. You can do this after the fact, but you can do it also while you're typing in the notes. The elevation, you maybe don't know the elevation in the field, but look at this. I can just hover on my lidar and it'll tell me the elevation there is 450. So I could go to that station and XYZ, set Z to 450. Now, even though I had no idea what slope to put into my traverse, I now have an elevation adjustment there, which will show the thing correctly in the profile in location design. Okay, so I've got a little traverse. It's got some information I've picked up in the field by walking on the ground, and now I can go back to my location design and create a new location design. I pick the same surface, of course I'm in totally the wrong folder. There we go. Pick the same surface and a P-line traverse. And now location design will create for me an alignment that follows the P-line. There it is. Picks up the cross sections from the lidar and picks up the profile from the lidar. However, at any point along here, I can see the P-line traverse and I can look at P-line traverse offset. So if I've got some ribbons in the field at that point there, I can see that, yep, I got a 10-meter offset here. I just moved my alignment over from the P-line. And unlike a P-line with side shots, you don't really have to worry about falling off the edge of the side shots. You can go anywhere you want because the lidar is everywhere. However, the offsets will get a little bit crazy after a while. Okay, that's all I wanted to cover for today. Thank you for your patience. And if you have any questions, feel free to type them into the questions area. Oh, here's a little quick point you might want to be aware of. We've got a creating a cut fill example on our website. And I found that just by typing in cut/fill into our search engine there. So that was earlier in the webinar when I showed you that green and red cut fill map. Well, I'm not seeing any questions. Thank you very much for your time, and we'll close off the webinar.
Thank you very much, everyone.
Oh.
We have a question.
Yes, I am not going to close the webinar. Still waiting for the fully typed question. Here we are. The question is, what are the number of fields you need to have values for from your lidar in order to have the location module features work? I'm going to interpret that as being what data needs to be in the lidar. Most lidar files contain data points that are both on the ground and on the foliage or power lines or buildings. And the lidar provider will separate them if you're lucky. LAS is typical of this. It'll have both ground points and other points in it, and you can select those at import time. All we need for RoadEng is three-dimensional ground points. That's it, nothing else. The georeferencing is nice, but it's totally optional. In fact, the data that came here was, luckily it was georeferenced. It was in UTM coordinates, but it doesn't get stored in the file. I had to look it up and set my coordinates later. But even if your lidar data is not georeferenced, and often photogrammetry data is not, it's just in a local coordinate system, location will still work fine. So not too much. Any other questions? Okay, that said, we're going to close down the webinar. Thank you again for attending, and see you in a couple of weeks.